Welcome back. Let's go over C and C++ implementation details. I want to go over some basic C and C++ features that relate to strings and unusual bases. So at the lowest level in C and in C++, a string is just a character array. Okay? Now there are higher level string classes in C. We don't need those. And even if you did use one of those, what you're going to end up doing is getting at the underlying character array that's in that string class. So don't use the string classes, just use a simple character array. All right? So here's one. I have a character array called num, and I've initialized it with the string 42. So these are the characters 4 and 2. So this is a string. It's a character array, but we also call that a string in C and in C++ sometimes. All right? So I'm just talking about a low-level character array, a low-level string. So the way that's stored in memory is like this. You have 3 bytes. A character is a byte. So this is a 3-byte array. When you leave the brackets empty in C, it counts the characters in the string and allocates enough memory. In this case, we need 3 bytes because there's a 0 at the end, the null terminator, right? So this is the ASCII character 4, this is the ASCII character 2, and then this is the number 0, right? So there's actual 0 stored in here, the value 0. Here, there's a character 4 stored. So the actual numeric value is whatever the ASCII value for the character 4 is. So look on an ASCII chart. And likewise for 2, this is the character 2 stored in here, and I put ticks around that to indicate that. But the numeric value that's stored in this byte is actually the decimal value for the character 2, which you could look up in an ASCII chart. So you could just output the string using cout, and it would come out on the screen, or you could use printf if you prefer. You could also access the individual elements of the array just using a loop here. So here I'm looping from 0 to 2. Well, length is 3, and so it stops at 2. And I'm just accessing num sub 0, num sub 1, num sub num sub. So I want this to stop at 1, and I'm not sure what length returns. I'm not sure if length returns the length including the null character. It must not. It must just return 2, just the length of the 42 part, because otherwise this wouldn't work. And I did run this and it works. So you could check that, print out what length is. It should be a 2. So anyway, I goes from 0 and then it goes to 1, and it prints out num sub 0 and num sub 1, and then I iterates one more time. I actually does go to the 2, but then the target statement of the cout does not execute because the conditional is false. Just some details about how the for loop runs. Anyway, so that's just the basic idea of a string character array in C and C++. Okay. Note right here that the indexes go 0, 1, 2. All right? Now that's opposite of how we've been looking at numbers by powers of the base, right? So let's assume that this 42 represents a base 6 number. Okay? So 42 in base 6, so base 6, 42, would have these column values. The column values would be powers of 6, 6 to the 0, 6, 1, 6 squared, or 1, 6, and 36. So notice that the 2 here is associated with the 0 power, and the 4 is associated with the 1 power. Okay, that's opposite of these indexes here, right? Here the 2 is under location 1, and the 4 is under location 0. So the default, the only way, to store a string in a character array in C, the indexes are going to be backwards from what we need. Okay, so you can deal with that and just work backwards in the string. That you can deal with that. Makes your code a little bit confusing. Your alternative is to take this order 4 and 2 and reverse it. Make it 2, 4, right? 2, 4, which would match 2, 4, going from right to left, okay? So just be aware of that. All right, let's say we wanted to do some conversions, okay? What if we want to convert this base 6 42 to decimal? Well, we're trying to write a program here. What does converting to decimal even mean? Let's just put it in an integer, all right? Let's just put this base 42 or base 6 string 42 into an integer I. Okay. So let's just do that. So I want 2 times 6 to the power 0. So that's happening right here, right? This is num sub 1, which is 2. And I'm multiplying that times 6 to the power 0. And then this guy over here is 4. And I'm multiplying that times 6 to the power 1. All right, so I'm doing this 2 times 6 to the power 0 and 4 times 6 to the power 1. Doing that here. Now what's going on with this minus character 0? Well, remember these are ASCII characters. This 4, it's not numeric 4, it's ASCII 4. So it has a ASCII value in there, which you could look up. But what I need is the value for, right? So if you subtract the character 0, you'll end up with 4 here. Likewise, if I subtract the character 0, I'll end up with 2 here. Okay, so go look at an ASCII chart. If this is a new trick for you, look at an ASCII chart and think about this. Okay, so where are we? We've got a string 42. This little snippet of code, I've taken that string 42, interpreted it as a base 6 number, and put it into an integer. Okay, what if I want to go the other way? That is, take an integer and put it into a string. Say I wanted to take that 42 out. So so 42 base 6 is 26 base 10. Okay, what if I want to take this 26 and put it back into a string? So here I'm declaring a integer and putting a 26 in it. So is that base 10? Where's the base 10? Let's just stop for a minute here and think about what's going on. When you write C code, you type numbers all the time, right? You're typing base 10 numbers. I mean, or they're interpreted as base 10 numbers. What are they really? They're strings. Like source code is just characters. Right? When you're typing source code, you're typing characters. So you type the character 2, you type the character 6 in code, you've really typed a string. But when this is compiled, those characters 2 and 6 are interpreted as a base 10 number. Okay, so the compiler is doing this conversion for you from string representation to a base 10 number. Right? Now it's a little bit weirder than that, because we know that in the memory location for an integer, it's really stored as binary. Okay? So let me just say that again. So you type out source code, which is all characters. You have a 2, 6, a character 2, and a character 6. When this compiles, it's translated, or it's interpreted as a base 10 number, but then that base 10 number is stored in binary format in the integer. Okay, so it's a little bit freaky, but that's what's happening. But we want to take this 26 right here, which we think of as a base 10 number. Okay, and we want to convert it to a base 6 representation in a string. So we're going to put the 42, which is the base 6 representation, we're going to put this in num. So I've allocated 3 bytes, because I know I need 3 bytes to store the digits 4, 2, and then 0. Then you need this null terminator on the end. You need the 0, so I'm explicitly writing the 0 on the end of the array there. And then you just do the mod div algorithm. So to get this 2, you mod the 26, right? I is 26, mod that by 6, and then convert it to a character All right, so this I mod 6 is really 26 26 mod 6, which is going to give you the value 2, and then I need to turn that into the character 2. So I add the 0 on there. Okay, then to get the mod div algorithm, the next step is to divide by 6. So I do that, and I do the mod again, and this will give me when I mod 26 by 6, I'm going to get 2 left over. Oh, I messed up. So the first one was a 4. This one's going to give me 4. Yeah, 26 mod 6 is wait a minute. No, that's 2. 6 goes into 26 4 times. That's 24, and so 26 minus 24 is 2. Should give me 2, the value 2, and then I convert that to the character 2, and I put it in there. Okay, great. Then I div, and I end up with 4. 26 divided by 6 should be 4. So then 4 mod 6 goes into 4 0 times with 4 left over. So this will be the numeric value 4. And then I add the character 0 to get the character 4. Div one more time, you end up with 0, which stops it. Okay, so really you should do this in a loop so that it can handle larger numbers. Likewise, this thing over here, you should do this in a loop so that it can handle larger numbers. All right? What about adding in the base? So I've pointed out already that the digits are stored backwards in a string, backwards from the way we normally think about the exponents. So to do the conversions that we've just done, you can deal with that backwardness, but to do this addition, it's really much easier if you just reverse the numbers, so reverse the digits. So that's what I've done. I've taken this 42 thing with indexes 0 and 1, and I've reversed the bit order, so I've drawn the indexes backwards here, right? So let's say we want to do 42 base 6 plus 53 base 6. First, maybe make some temporary character arrays and reverse all the characters, so it'll be like this: 4 2 and 5 3 with the indexes going this way. Okay, then you're just going to add and then do mod div, right? So you're going to add 2 plus 3, you get a 5, and so you just write that there. Or really, 2 plus 3 is 5, then you modulo by 6, and you get 5. So you write it on here. And then the carry, this 0, is dividing 5 by 6, which is 0. Okay? You do that again, so then you get 4 plus 5 is 9. And you modulo by 6, and you get the 3. Then you divide by 6, and you get the 1. Okay, and you just keep going for all of these digits. Here it stops, or it's done here, but you'd keep going for, in this case I made an 8-character array. All right, an 8-element string. Okay, so yeah, I would reverse the order, add these guys like that, and then flip the order back to put them into regular string order. Put the characters back into regular string order, and then don't forget to put the null terminator on the end of the string. Okay, that's the theory. Let's take a minute to look at the code. All right, so I'm going to pause this and go over to the screen. Okay, I've got the assignment pulled up. So I want you to be able to write code for what we just talked about. So convert integers into arbitrary bases, bases back into integers, and then add two numbers of arbitrary base. And I want you to add them in the base. Okay, so use this symbol set that we've been using. It goes up to 35. So this will support up to base 36. I'm giving you some helper code. I'm basically asking you to write these 4 functions right here. Okay, so the first one So there's a library function called a2i, alphanumeric to integer. I want you to write your own. That's why I've had the name my a2i, because you're writing your own version of a2i. And this one converts a string representation of a positional number system in some arbitrary base to an integer. So you pass the string in there, like you could pass 42 in there as a string, and then you could pass the 6 in there, and it would convert this to base 10 and put the answer in the return value. Okay, and this guy here does the opposite of that. It takes an integer, like you could pass 26 in there, and then you could pass a 6, and then this string here would contain the base 6 representation of that integer, long integer. Okay? And then I want you to do that with some weird symbols. So here, normally we use this 0 through z. I talked about in the notes a little bit of how these are just arbitrary. And instead of 0, 1, 2, 3, you could use some letter sequence, right? Anything, some letter sequence. So I want you to use a particular letter sequence instead of the digits 0, 1, 2, 3. So what are you really going to do? You're going to convert to base 4. Well, yeah, you're going to convert to base 4, right? So you'll just be using the digits 0, 1, 2, 3. And then after you've done that, then you're just going to convert the 0, 1, 2, 3 into some other letter set. All right? That's what I mean by a DNA 3 codon sequence. And then I want you to add 2 numbers of arbitrary base in the base. So you'd pass a number S1 by reference into this thing, and then you'd pass a number S2 by reference into this thing, and you'd pass a buffer to contain the answer into this thing, and then you'd pass the base that these guys are both in, and then when this function's done, the answer should be in sum, right? I have the code pulled up here. I've got a template code that talks about what I'm asking you to do, and then I've provided you with 4 let's go write that one. I've provided you with 4 templates. There's these 3 that are just empty, and then here's the 4th one that's empty. Okay, it looks like I've implemented I've implemented one that goes from codon to integer, and I want you to go from integer to codon. So the reason I've given you this is just to help you out with the character mapping. Here I'm mapping letters to numbers, but I want you to map numbers to letters. Okay, and yeah, so write these 3 functions. It's very similar to the code that I've presented in the notes, except of course I want you to write loops. I want you to use some loops so that it'll work on longer strings. And then here's an example down at the bottom of testing it, right? So main is just a driver program. It's just a test program. You can hard code your input and your output in here. And so like, let's see, here I've got a string 1, 6, and I'm passing that 1, 6 into this function, and I'm telling the function that it's a base 36 number, and when this function returns, n should contain the integer representation of 16 base 36, and then it's going to print that out here. And then you can go backwards. You can pass whatever the answer to this first one was. You can pass that. No, wait. This contains a return value, right? So I'm passing the answer. See this output buffer right here. So I'm creating an output buffer. I'm passing a pointer to that output buffer into this function. This will contain the answer. N is the input value. 11 is the other input value, that's the base. Right? So n is the integer inputting 11 is the base that I'm inputting, and S out will contain the answer. Okay, and then here's testing the gene one to see if it works, and then going back, and then here I'm adding, down here I'm adding two strings represented as a base 6, right? I'm adding the string 543 and the string 210. So I'm declaring the input buffers, and then here's an output buffer, and I'm passing the two input values as strings into the function, and then I'm receiving the answer back in sum, and then I'm telling the function that that these are base 6 numbers. Okay, so this is a fairly straightforward program. You shouldn't have too much trouble on this once you understand what it is I'm asking you to do. So get this all working, and take your here. Let me go ahead and just make a nice document, right? Go your name, the CISP 440, and assignment. Assignment 1, and well, make that big and pretty. Maybe put a cartoon. Put a cartoon in here somewhere, and then format it pretty, and put your source code in there. Take all this source code and change the header. Put in your name, assignment, date, class, what you changed, right? Etc. Anything else you want. Credit to the author, right? Or credit to Ross. It's just like a reference. That's how you avoid plagiarism, is saying that source code provided by Ross, and like that. Then copy all of this stuff and paste it in here. Oops, didn't get it. Control C, Control V, paste. And the other thing I'd like you to do is capture the output and see if this thing runs. No, I don't have the project set up. This is just empty source code. But I want you to run the thing and get some output, and then capture this screen, right? You can press Alt print screen, and paste that in there. That's just proof that your code ran, right? And then give me all your output, all your output, right? And make some nice headings. Make nice headings for all of this stuff, right? Okay, source. I want to see your source. I want to see a capture of this command prompt to prove that it worked, and then I'd like to see you cut and paste, all of the testing output, and add more testing output to this. Here I've just done I've called these guys once, and that's the absolute minimum you should do. But you should really make up some more numbers, right? Make up some more function calls with different numbers and call these guys several times. All right, and then save the whole thing. Export this whole thing as a PDF. Okay, and on the desktop, and then email me that. Okay, email me that PDF. Right here, this generate a PDF nicely formatted, and email it to me. You spend some time on the headings and the organization of it, and make it look pretty, and email that to me. All right? Okay. Thanks.